The standard burial depth for an underground feeder in a single-family dwelling is 24 inches, as outlined in Table 300.5 of the National Electrical Code, commonly referred to as the NEC. However, there is an exception that allows for a reduced burial depth of 18 inches in specific circumstances. This exception applies only when the underground feeder cable is installed beneath driveways and parking areas. The rationale behind this exception lies in the practical difficulties that may arise when attempting to excavate a trench to a depth of 24 inches under paved surfaces like driveways. The code recognizes that such excavations can be challenging and potentially disruptive, and therefore provides a provision for a shallower burial depth in these instances. It is important to understand that this 18-inch burial depth is not a blanket allowance for the entire underground feeder installation. It is specifically limited to the portion of the cable run that passes beneath the driveway or parking area. For all other sections of the underground feeder, the 24-inch burial depth requirement remains in effect. The purpose of the 24-inch burial depth is to provide adequate protection for the underground feeder cable from potential damage. Underground cables are susceptible to damage from various sources, including digging, construction activities, and even natural events like ground movement or frost heave. By burying the cable at a depth of 24 inches, a reasonable level of protection is achieved, reducing the risk of accidental damage that could lead to electrical hazards or service interruptions. In essence, the NEC establishes a standard burial depth of 24 inches for underground feeders to ensure safety and reliability. The exception for driveway and parking area installations is a practical consideration that acknowledges the challenges of excavating under paved surfaces, but it does not negate the overall requirement for adequate protection of the cable. When installing an underground feeder, it is crucial to carefully assess the entire cable run and determine whether any portion of it will pass under a driveway or parking area. If so, the 18-inch burial depth may be applied to that specific section, while the remaining sections must adhere to the 24-inch requirement. It is also important to consult with local electrical inspectors to ensure compliance with any additional requirements or interpretations that may be specific to a particular jurisdiction. The NEC is a comprehensive document, and its application can sometimes be subject to varying interpretations. Local inspectors are familiar with the specific nuances of the code in their area and can provide valuable guidance to ensure that the installation meets all applicable requirements. Furthermore, it is always advisable to use appropriate underground feeder cable that is specifically designed and rated for direct burial. These cables are constructed with robust insulation and jacketing materials that can withstand the harsh conditions encountered underground, including moisture, abrasion, and temperature variations. Using the correct type of cable is essential for ensuring the long-term reliability and safety of the underground feeder installation. To summarize, the NEC mandates a 24-inch burial depth for underground feeders in single-family dwellings, with an exception allowing for 18 inches under driveways and parking areas. This exception is intended to address practical challenges associated with excavation under paved surfaces, but it does not supersede the overall requirement for adequate protection of the cable. When installing an underground feeder, it is crucial to carefully assess the cable run, adhere to the applicable burial depths, use appropriate underground rated cable, and consult with local electrical inspectors to ensure compliance with all relevant requirements. Understanding the nuances of the NEC and applying it correctly is essential for ensuring the safety and reliability of electrical installations. Failing to comply with the code can lead to hazardous conditions, service interruptions, and potential legal liabilities. Therefore, it is always recommended to seek guidance from qualified electrical professionals who have the knowledge and experience to ensure that electrical work is performed safely and in accordance with all applicable regulations. Remember, electricity is a powerful force that can be dangerous if not handled properly. Always prioritize safety and seek expert advice when working with electrical systems. The NEC is a valuable resource that provides the necessary guidelines to ensure safe and reliable electrical installations. By understanding and following the code, you can protect yourself, your family, and your property from the hazards associated with electricity. In addition to the burial depth requirements, there are other important considerations when installing underground feeders. Firstly, the cable must be installed in a manner that protects it from physical damage. This can be achieved by using rigid metal conduit, intermediate metal conduit, or Schedule 80 PVC conduit in areas where the cable is exposed to potential impact or abrasion. Secondly, the cable must be properly supported and secured to prevent strain on the connections. This is typically accomplished by using cable ties, straps, or other approved methods. Thirdly, the cable must be installed in a trench that is free of sharp objects or debris that could damage the cable insulation. The trench should be backfilled with clean soil or sand to provide a smooth and uniform bedding for the cable. Fourthly, the cable must be clearly marked to indicate its presence and prevent accidental digging or damage. This can be achieved by burying a warning tape or placing markers along the cable route. Fifthly, all connections must be made in approved junction boxes or enclosures that are rated for underground use. The connections must be properly tightened and insulated to prevent moisture from entering and causing corrosion. Sixthly, the cable must be properly grounded to provide a path for fault current to flow back to the source in the event of a short circuit. This is typically accomplished by connecting the cable's grounding conductor to a grounding electrode system, such as a ground rod or a metallic water pipe. Seventhly, the cable must be inspected by a qualified electrical inspector before it is energized to ensure that it meets all applicable requirements. The inspector will verify that the cable is properly installed, protected, and grounded, and that all connections are made correctly. These are just some of the many important considerations when installing underground feeders. It is essential to consult with a qualified electrical professional to ensure that the installation is performed safely and in accordance with all applicable codes and regulations. Remember, electricity is a powerful force that can be dangerous if not handled properly. Always prioritize safety and seek expert advice when working with electrical systems. Now, let's delve a bit deeper into the specifics of Table 300.5 of the NEC, which governs the minimum cover requirements for underground conductors and cables. This table is a critical resource for anyone involved in the installation of underground electrical systems, as it provides the necessary guidelines to ensure the safety and reliability of these installations. The table is organized into several columns, each addressing different types of wiring methods and installation locations. The first column specifies the wiring method, such as direct burial cables, rigid metal conduit, or intermediate metal conduit. The second column describes the location of the installation, such as under driveways, under buildings, or in residential properties. The remaining columns provide the minimum cover requirements, expressed in inches, for each combination of wiring method and location. As we've already discussed, the table specifies a minimum cover depth of 24 inches for underground feeder cables in residential properties. However, it also allows for a reduced cover depth of 18 inches when the cables are installed under driveways or parking areas. It is important to note that these are minimum requirements, and in some cases, it may be necessary to provide additional cover to protect the cables from physical damage. For example, in areas where there is heavy vehicular traffic or where the soil is particularly rocky, it may be prudent to increase the cover depth to provide a greater margin of safety. The table also includes provisions for other types of wiring methods, such as rigid metal conduit and intermediate metal conduit. These wiring methods offer a higher degree of protection for the conductors and cables, and therefore, the minimum cover requirements are generally less stringent. For example, rigid metal conduit requires a minimum cover depth of only 6 inches under driveways and parking areas, and 12 inches in other locations. Intermediate metal conduit requires a minimum cover depth of 6 inches under driveways and parking areas, and 18 inches in other locations. When selecting a wiring method for an underground installation, it is important to consider the specific conditions of the site, including the type of soil, the level of vehicular traffic, and the potential for physical damage. In general, rigid metal conduit and intermediate metal conduit offer the best protection for the conductors and cables, but they are also more expensive to install. Direct burial cables are a more economical option, but they require a greater degree of care during installation to ensure that they are properly protected from physical damage. In addition to the minimum cover requirements, Table 300.5 also includes several notes that provide additional guidance on the installation of underground conductors and cables. For example, Note 4 states that the cover requirements apply to all locations that are subject to vehicular traffic, including driveways, parking areas, and roadways. Note 5 states that the cover requirements apply to all locations that are subject to physical damage, including areas where there is a high risk of digging or excavation. Note 6 states that the cover requirements may be reduced by 6 inches for installations that are encased in concrete. These notes are important to consider when planning an underground installation, as they can help to ensure that the conductors and cables are properly protected from damage. Finally, it is important to remember that Table 300.5 is just one part of the NEC, and it should be used in conjunction with other relevant sections of the code. For example, Section 300.5d provides additional requirements for the protection of underground conductors and cables from physical damage. Section 310.15 provides requirements for the ampacity of conductors, which must be considered when selecting the size of the conductors for an underground installation. By carefully considering all of the relevant sections of the NEC, you can ensure that your underground electrical installation is safe, reliable, and compliant with all applicable codes and regulations.